Hi, my name is Claire. I'm the founder of the TYPANNOT'S project. TYPANNOT'S is an ongoing project that aims at creating an innovative typographic system to transcribe sign languages. Today, I'm here to present the linguistic part of our team and to introduce sign language studies.
Hi, my name is Morgan. In the team, I have specialized in type design and type engineering.
Hi, my name is Adrien. I'm a designer and type designer. And within the TYPANNOT'S project, I'm the person that has worked most on the mouth action system. Together with Morgan, Claire, and other members of our team, we have combined our forces to set up and design a typeface for mouth actions, and that's what we're going to show you today.
Before we get in the depth of the project, let me briefly introduce our team. The team that is behind the TYPANNOT'S project is called Gestural Script and brings together researchers, linguists, designers, and programmers. It all started as my student project in the Art and Design School of Adrien. Now, a little more than 10 years later, is involved around 10 steady members working together. Now that you know more about us, let me introduce sign language and the issue of the annotation for those who are not familiar with it. Sorry.
On a un petit que je...
No, it's okay. Okay. We all know what sign language is, but one common misconception is that there is only one sign language, and that's not true. There are actually 142 sign languages across the world. All sign languages have a common structure, but they all have some differences that mostly come from cultural heritage. One thing that all sign languages have in common is that they are multimodal, meaning that the language is expressed with several modalities. This is different from spoken language that has only one modality, the sound created by our mouth. In a nutshell, sign languages use the shape of the hand, the position of the arms, the facial expression, and the movement of each of these parameters to create meaning. Okay, now let's briefly talk about annotation. To study sign languages, linguists annotate pieces of speech, and do that they use software like this one called ELAN, which is important and simple of video. The signs are then analyzed and they are annotated in English, German, French, depending on the nationality of the annotator. This is very interesting for analyzing the meaning of the speech, but analyzing how the meaning is carried or created by the signs is problematic when the alphabet you are using to transcribe gestural language is based on sound. Why is that? Well, a letter only carries acoustic information, and using sound-based letters to transcribe gestures doesn't seem to be ideal, especially if you want to have a structural analysis on the language. In order to stay closer to the original language, there is a need for a transcription system that can hold more information. And that is where TYPANNOT'S comes into play. So, but before showing you the work we have done, Adrien is going to tell you more about mouth gestures or more mouth actions.
Thanks, Claire. Sorry, we have a little glitch on the screen, so we have to kind of move this thing every time we pass a slide, but we're going to try to do that smoothly during the presentation. As Claire mentioned, there are multiple parameters in sign languages. Today, we're solely going to focus on the face, and more specifically on the lower part of the face, the mouth, which carries significant meaning in sign languages. In spoken languages, facial expressions are considered nonverbal communication. It's quite different in sign languages. Facial expression, and more specifically mouth actions, play an important role in the language itself. In fact, a lot of manual signs are accompanied by mouth actions. These actions can bring complementary meaning to the sign, or they can be required to achieve the sign correctly. Even though the research on mouth action is much more rare than on parameters like hand shapes, there are very interesting studies about the role, the frequency, and the interactions of mouth actions in sign languages. Okay, that's all for our introduction on mouth actions. Let's get back to the main topic, our work on the TYPANNOT typographic transcription system for mouth actions. So today we will start by a brief literature review on the subject. Then we will tell you about the TYPANNOT approach. We will show you the system we are designing, and then let you know more about our design process. To finish, we will tell you about the next steps to finalize the work. For our literature review, today we'll concentrate on sign writing, which is one of the most commonly used systems for sign language. It doesn't mean that it's the only work that has been done on the subject, but most transcription systems or attempts to create systems haven't achieved a comprehensive solution yet. This is an extract of mouth and facial signs in sign writing. Sign writing is a visuospatial system. It uses symbolic signs that can code simple actions, and also contains morphological characters. And those can be combined to create simple facial expressions. And that's rather easy and intuitive to understand. But it comes with some limitations, mainly because there isn't a fine granularity in the description. Here you can see 10 signs that can be used to transcribe an open mouth. Simple, but not very precise. And also, in this example, our mouth can be opened either because we opened our jaw or because we pushed our lips apart. And with such a system, we can't really tell what is happening. Okay, so is there another way to be more precise? Well, to do this, it can be useful to take a different approach. I just told you that sign writing was a visuospatial system. A visuospatial system means that the information carried by the sign is the outer shape that can be witnessed by an observer. With the TYPANNOT project, we have a different approach. In order to remain closer to the act of signing and to retain more pieces of information, we have taken an articulatory approach. We're now going to show you how it works. Morgane, can you tell us more about the TYPANNOT font family?
Sure. The TYPANNOT system is a typographic system that aims at transcribing all parameters of sign languages. For each parameters, we are working on a typeface, each of which will be grouped in what we could call the TYPANNOT font family. We have different levels of completion in our task. EndShape is the most advanced system, but today we are here to show for the very first time our work on mouth action. Here is a quick overview of our current font. I'm saying current because even if we have done a lot... Oh, on a perdu une fenêtre. I'm saying current because even if we have done a lot of work already, it isn't set in stone yet. We are still tweaking some minor details. But this is a little fast. Let's slow it down a bit. Adrien, would you walk us through a few glyphs?
Sure. Hopefully we won't have this glitch happening on those glyphs. This is my mouth in a neutral position. And this is what happens if I open my jaw and if I break it, actually. Here, push the opening to the maximum. Hopefully you can see that, right? And back to neutral. Here, I push my lips forward in protrusion. And the opposite, I suck them inward. And here, I puff my cheeks. And back to neutral again. I open my jaw again and stick my tongue out. And then I push my upper lip up and touch my upper teeth with my tongue. Without too much explanation, I'm sure you can start to see the potential combinations and the logic behind the glyphs. Here is a grid that displays a couple features of our system. All right, that seems pretty nice, but you might be asking yourself a question. Didn't you say that the TYPANNOT'S system was more than a visual spatial system? And here, I'm just seeing the shape of the mouth from an outer point of view, right? And the answer is yes. And to see how it is more than that, we're going to go deeper in the making of the system. Morgan, can you show us how the formula works?
Yes. At the root of the typeface that you just saw is a formula, a mathematic formula. This formula is based on an X, Y, Z grid, which means that our different mouth parts can each move on Y, Z axis. And moving our mouth part on this axis will result in a mouth signs. This grid is the best way to be efficient in describing all morphological possibilities. Let me show you a couple examples. Here, the lips are 4 and up. Here, the corner of the lips are diverging horizontally, which creates a stretch. And they are up, which results in a smile. Here, the jaw is diverging to its maximum position. Here, the upper lip is pushed up, and the lower lip is tucked back. This is how the formula is organized. First, you have a parameter, for us here, the mouth. Each parameter is divided into different parts. For the mouth, you will find the jaw, the lips, vermilion and corners, the tongue, and the use of hair. On each of these parts can be applied certain types of variation: vergence, position, contact, etc. And this variation each have a set of values: neutral, divergent, convergent, up, down, etc. Using this formula, you can describe any mouth action in any sign language. And in order to make this formula a little more visual and compact, we created a series of symbolic characters. Here is the last example with our formula translated into symbolic characters. Okay. Now we have the formula and we have the symbolic characters. But what about the morphological glyphs? How does this apply to them? Well, morphological glyphs are only a different visualization of a symbolic character string compounded into only one glyph. You might be asking yourself, How does this work? Well, we are using typographic ligature. By using ligatures, we can compound a string of symbolic characters into one morphological glyph, which means that both of these visualizations are accessible to our users at any time on any given software. You can just switch from one to the other. You can display the global intuitive morphological glyph or analyze all the different physical components that come to play to create that sign. And that becomes very interesting for data mining purposes. Now that you have seen the way our typographic system works, we would like to take a moment to talk to you about the work process that got us here. I'm going to let Adrien tell you about it.
Yes, altogether, it took us a few years to set up this system for mouth actions, and the process is quite interesting. Today, I'm going to let you know about the design process of the morphological glyphs. Designing this glyphic system was quite a daunting task, to be honest. There are so many possible combinations. Our brain is capable of distinguishing so many subtleties on the human face. How do you turn this into a font? A font that is legible even at a small scale? Well, when faced with the highly complex issue, a good approach is to start at the very bottom with very simple tasks and gradually work your way up. One very useful thing that we did while we were working on the formula was to take a lot of pictures. Okay, you can see a few examples here. So using these pictures, I decided to start drawing different mouth parts to get familiarized with the shape of the mouth and understand what are its most recognizable components. Then matching some pictures with the drawing, I worked on making the lines as simple as possible. Then finally, I transferred this drawing to a vector software. Here are some early results. And with that, we ended up with a set of early work in progress that was rather encouraging. But it's important to note that this was a short list of very simple glyphs. In this example, there are only 2 values that have been given either to the lips or to the jaw. And when you add more values, it gets really complicated fast. And glyphs are not drawings. They need to be legible at a very small size. And if you solely base your design on morphological assets, the differences between glyphs displayed at a small scales won't be identifiable at all. Another way to go would be to forget about morphology and have a more symbolic approach. If you go radical, the symbolic approach would end up with dots, dashes, crosses, and arrows. The shapes are very easy to tell apart. But in order to transcribe all the possible combinations of mouth actions, we would end up with a system that requires a lot of symbols combined to make just one glyph. It would end up being rather similar to what we already have with the symbolic characters. And that is much closer to a coding system than a proper typeface. The answer to the problem was somewhere in between these 2 options. If we have a continuum on one side morphology and on the other side symbolism, the best answer is somewhere in between. So Morgan and I tested some options, more towards symbolic or more towards morphology, and testing it on a selection of around 120 glyphs. Very early in the process, we started to work with the grid to rationalize the shapes, sizes, and positions of the different components. It was very important to make sure that we were being consistent in our work. And slowly but surely, we got closer and closer to the optimal system. a hybrid between morphology and symbolism, a little more closer to morphology, to be intuitive, but that uses symbolic shapes in key places to simplify the whole system. Since then, we extended the results to about 150 glyphs to make sure we had all needs covered. And that is where we stand today in the process. But the work is actually far from being done. First, we need to apply the same process to the upper part of the face. We're actually well on our way, but we're going to keep that for another presentation. And to wrap up our presentation, I'm going to let Morgan walk you through the next phases of our process to complete the mouth action system typeface.
Yes. Now that the type has been designed, we are going to go into some engineering. Here you can see our morphological components. This glyph will be organized to follow the rules of the Unicode Consortium. And when we are ready, we will apply to get them integrated into Unicode so that anyone in the world can access them. And because they are neatly organized, we can use scripts to combine them into the thousands of possible combinations. To do this, we will use this RoboFont plugin that was programmed by Mathieu Reguet for our N-shape font. The examples that you see at the screen are for N-shapes. This plugin converts the rules we have defined when designing our grid and transform them into scripts to combine glyphs automatically. These scripts are based on anchors that can either be used for the positioning of other components or to create interpolation. At the end of this process, we will have a complete typeface. As you can see, there is still a lot to do. And we didn't want to wait for the font to be completely finished to put it to good use. That is why Chloé Thomas, a member of our team, is already using the symbolic characters to transcribe mouth action corpora for her thesis, focus on head and mouth action in interrogative speech. And she has been giving us great feedback along the way. That's all for today. On behalf of all the GestualScript team, thanks a lot for your attention, and we are here to answer any of your questions.
Thank you. Any questions?
So you're working on 4 typefaces, so for hand shape, movement, face action, etc. Would it be possible, though maybe quite technically complex, to maybe by using ligatures, combine these 4 typefaces to describe one total sign word?
So in the first place, those types are not meant to do this because linguists often separate on different lines, different parameters when they're annotating. So that's not the first purpose, but you can combine them together yourself. We haven't really thought about a way to automatically combine all of them, because right now we don't really have all the fonts done, but we have already done combinations ourselves to transcribe a whole sign into a typographic picture. We've done that by hand, I would say, and that would be quite interesting to see. And I think we actually have the technology to do it, but we need some more fonts.
Okay, and
Thanks for your question.
any reason why the fonts are split in several files? Because if you, as you said, you're going to you'll want your characters in Unicode, but I guess the hand shape ones are different from the face action ones. So you could imagine having one single typeface as all the different characteristics will be on different code points.
I'm not sure I understood completely your question, because could you repeat it a little louder, because we can't hear the microphone very well.
You said you're generating 4 typefaces.
Yeah.
But my understanding is that each typeface will describe, we'll have different code points, because Unicode code points, because some will be for the face, some will be for the hands, etc. So could it also be imagined to have a single typeface with all the different components from the 4 other ones?
What? Parce qu'en fait, il y a que 65 000 caractères.
Well, so we could, but it would bring some limitation. And the reason is that the combinations, the number of combination by parameter is very, very high.
Mm-hmm.
It's actually higher than what a font can hold. A font can only hold 60,000 glyphs in it. And for each parameters, we actually have more than 60. So the way we're going to address this problem is that we're going to let the community of linguists and researchers ask us for the glyphs they need. So we will implement them in the font. And so we could make only one, but then we would have to divide 60,000 by the 4 parameters that we have. So it would bring more limitations in a way.
Okay, thank you.
Thanks for your question.
Thank you. That was really, really fascinating. And it looks like a wonderful job of implementing a very difficult problem. I was wondering if your goal of this is to accommodate every single sign language that exists, if that's theoretically possible, if this is an equivalent to an IPA for sign languages.
Yes, as you can see, for this example, more specifically, there are not a lot of corpora that has been done on what mouth actions are used. There has been some, but it's only on Italian or British Sign Language. We don't have like a global view. So what we did for this formula is we really tried to be not too complicated, not too fine in the granularity on how we're making the mouth move, but actually we can note whatever you would do with your mouth, whether it's from sign language or not. So whether it's from one sign language or another, the idea is to have a system that's really universal. And that's true for all parameters, yes.
Okay, thank you very much.
Thanks a lot. Oh, I think we might have a question here online. I don't know. I'm not sure.
Yes.
I think Terry.
Terry Joyce.
Terry?
Yeah, is the time? I thought you were moving on again. I appreciate the focus on the accurately depicting the mouth shapes, but given that there are these 4 different components that you have to combine, how will they be represented and represent transitions? When all the elements are combined, I just wonder whether this level of detail would verge on information overload in the pictorial.
Okay, so if we the idea of such a font is to be combined with another font that we are working on right now, but it is not as completed, which is the movement font. So what you would be doing is to use a mouth action that's like a keyframe, and then you would set it in movement using the movement font. So you would not be taking, for example, for a mouth action, you wouldn't be taking several pictures of what this mouse action evolves into space, you would take one that's an initial position, and then you would apply movement to it. That's the route that we're taking, and the movement face typeface is actually being worked on right now, but it's the most complicated font to create for the formula as well as for the glyphs, and that will require for us to work a few years more before being able to fully have those two fonts working together. I hope this answers your question.
Yeah, it just seems that you're actually creating an animation of the signed elements. I mean, you know, sign writing does it frame by frame and the transitions, but really what you seem to be creating when you put all of these elements together and make them move, if you're going to have the mouth movements doing it in one location, you're making an animation, right? In a sense, yeah?
Yeah, so the glyph itself will not be animated, but you will have a complementary movement typeface that will indicate what direction the glyph is taking. And
well, that's my question. How do they combine to allow that to be something that's interpretable? So
that will have to be worked on, whether it's on two different lines or whether they can be integrated via programming, engineering, type engineering.
Right. To be solved, yeah.
The answer right now. But basically, yes, we think that using a key position and then setting it to movement will give you a whole lot of information. And if a mouth action is too complex, then you can take another keyframe and then set that one to movement again. But again, this is just a preliminary hypothesis.
Thank you.
Okay, and of course, the next step would be to apply Richard Sproat's algorithm to find out whether it's a writing system or not.
Excuse me?
First keynote talk, Richard Sproat showed an algorithm for determining a writing system, so we could apply it to your corpus.
Yes, there's one element that we didn't show today is the keyboard that we have created. So we created an interface that you can use to make all those different combinations, because if you only have the font, it's rather hard to use. So we have an interface that you can use. And if you're interested in that, you can go check our presentation for Graphimatic in 2020 or our TYPANNOT.fr website that will be online in about 2 weeks. We'll have more information on that here. Thanks.
Okay, thank you very much.